Welcome back, everybody. This is our ninth session in JEE Mains previous year questions for chapter Ray Optics and Optical Instruments of class 12th. Before this session, we have made 8 videos in this series, and all of those videos are available on our YouTube channel's playlist section. And if some of your friends are preparing for NEET, so we have videos also there regarding NEET previous years. So you can guide them through those videos, and if you find these videos helpful, useful, then do press the like button, share them, and subscribe to our channel. Your share and subscribe helps a lot. Also, if you like to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. With this, let's start today's video. In the previous one, we covered to around question number 66. This was the last question which we covered, and today we will start with the next one. So here we have that a student measures the focal length of a convex lens by putting an object pin at a distance u from the lens and measuring distance v on the image pin. The graph between u and v plotted by the student should look like. So we have to find that what it should look like. Now, as in the previous question, we already covered this, that graph will might look like this. We just need to plot it again with the proper coordinate system. So, suppose this is our x and y coordinate in the positive sense, and let me add the negative line here also, because normally what we will do when we measure, normally u is negative. So here we will have u here and v here. Now for a lens, we know we have the lens formula that 1 by v minus 1 by u is equal to 1 by f. Here f is constant. So from this we can write 1 by v is equal to 1 by f plus 1 by u. This will give us u plus f by fu, and from that v becomes fu by u plus f. Now if we discuss cases that when initially u is infinite, and basically it is going to be minus infinite because u is considered negative when it is object is in the left side of the lens. So when u is infinite, so what we will get? We will get v is equal to f, and when we have the opposite case, that when u is equal to minus f, then we have v is equal to infinite. And we also have the case of 2f, that when u is equal to minus of 2f, then v will be equal to twice of the f. So now let us mark some point regarding f and 2f on the coordinate axis. So suppose this line represents f on the u line, and this line represents f on the v line. Now we also need to have 2f, so this will be supposed that is 2f on the u line, and this belongs to 2f on the v line. So if I mark this, okay, and I need to extend this line also for the both of f lines, because image distance and object distance don't go beyond these lines for real images only. So what will happen? And here we are discussing regarding only real images. So for real images, maximum value of u is minus infinite and minimum value of u is minus f. So u will vary from infinite to up to this point. And similarly for the v, that for the real images, maximum value of v is infinite and minimum value of v is f. So we will not go beyond this line. So our curve will look like something like this, that it will pass like this. It will pass a point of 2f to f where both u and v are equal, and after that it will move like this along the both axes. So it matches here with the option C. So C is the right answer, although it could be taken as option B also. But here, as it is not clearly mentioned that whether we are taking U or modulus of U. If we are taking modulus of U, then B can also be a right answer. But we are taking it with proper sign. So only option C will be the right answer. Now let's move ahead. Two lenses of power minus 15 diopter and plus 5 diopter are in contact with each other. The focal length of the combination is. So we know that combined power of the system will be P1 plus P2, and that will be minus 15 plus 5, that will be minus of 10 diopter, and power is equal to 1 by focal length. So from this focal length is 1 by power, and this is negative 1 by 10, so it will be minus zero point 0.1 meter, or that will be minus 10 of centimeter. So option C is the right answer here. Now for the next one, a thin glass refractive index 1.5 lens have optical power of minus 5 diopter in air. The optical power of the liquid in the liquid medium with the refractive index 1.6 will be. So here optical, we have optical power mentioned. So we can say power is equal to minus of 5. So from this focal length will be equal to minus 1 by 5, and it will be in the meters. So now from the lens maker's formula we know that 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. That is, suppose in air. So this is the focal length in air. Now inside the liquid, what will happen? We will have fl, that is focal length inside the liquid. That will be refractive index of the glass divided by the refractive index of the medium. That is 1.6 here. So I write 1.6 minus 1, and radius of curvature will stay the same. Now, this is equal to the normal power or power in air, and this is equal to the power in liquid. So if we divide both of these equations, we will get power in air by power in liquid will be equal to mu minus 1, that is 1.5 minus 1 divided by 1.5 divided by 1.6 minus of 1, and this radius term gets cancelled as they are unchanged and they are equal in both cases. So here that is initially minus 5. So this is minus 5 by P of L is equal to 0.5 into, we will get 1.6, and here we will get negative of 0.1. So this negative sign cancels, and this zero point 0.1 cancels 0.5 on 5. So from this PL will be equal to, it will be 1 by 5 into 1.6 here, and this 1.6 can be written as 10 by 16. So this will be on 2, and this will go on 8. So this is 1 by 8 diopter. And if we see here that whether some is matching or not, here this is 0.5, 1.6, okay, so all thing matches. So none of these options are right here. So none of the we can say here we have problem with the given options. Now for the next one, we have a plano convex lens of refractive index 1.5 and radius of curvature 30 centimeter is silvered at a curved surface. Now the lens has been used for the image of the object. At what distance from this lens an object is placed in order to have a real image of size of the object? So suppose this is our lens. This is our lens, and what we had done, we have silvered one of its surface. So suppose this surface is silvered. So how light will behave now? So suppose this is the principal axis. So how light will behave? That suppose there is some source of light. So light from source will go like this. Now it will bend, then it will get reflected from the mirror, then it will get again refracted, and it will now form some image. And as mentioned here, that image and the object are the same, because we have a real image and it is of the size of the object, and this system will act as a mirror. And for mirror, that is only possible when we have an object as at 2f, so that image is real inverted and of the same size of the object. So this light will go like this, and here it will form the final image. So to solve this combined system, what we will use? We will use the formula that power of the system will be equal to twice the power of lens plus power of the mirror. Now, power of the lens we have to calculate. So power of the lens will be equal to 1 by FL, that will be equal to mu minus 1 into 1 by R1 minus 1 by R2. Refractive index of the glass is zero point 0.5, so this will be zero point 0.5, 1.5 minus 1 or zero point 0.5 into, we will have 1 by 30 plus 1 by 30, so this will be 2 by 30, and this will be 1 by 2, so this will be basically 1 by 30. So we need to make a correction here, that is, it is a plano convex lens. It is a plano convex lens, so actually lens is like this, there is no this side. So nothing will change, only this first radius of curvature will become infinite. So this will be infinite, and we will get power of lens as 1 by 60. And now we can write this formula that it will be 2 by 60 plus power of the mirror created here. So power of the mirror, as this our mirror will look like this. So it will act as a concave mirror, and its power will be negative, and that will be equal to 1 by the focal length. Focal length will be half of the radius of curvature. Radius of curvature is 13, so that will be minus 50. So what we will get? We will get 1 by 30 minus, we can write it like 2 by 30. So this will be minus 1 by 30. So we can say focal length of the system, that will be act as minus 30 centimeter. Now we know that this given criteria is fulfilled when object is at 2f. So that 2f will be equal to 60 centimeter, and that is option A here. Now let us move to the next one. The surface of a metal is illuminated alternatively with the photons of energy 4 electron volt and 2.5 electron volt respectively. The ratio of maximum speed of the photoelectron emitted in the two cases, the work function of the metal is. So we know this is related to photoelectric effect. So half of mv square, that is the maximum kinetic energy, is equal to h phi, nu minus phi, where h nu is the incident energy. So uh, here we have the ratio of speeds. So let us write it in the ratio form. So half m v2 square divided by initial energy is 4 electron volt minus 5. Sorry, let me correct this. Divided by half m v1 square, and here we will get 2.5 minus 5. So half m get cancelled. Now v2 by v1, that is given 2, and whole square will give us 4. So 4 equal to 4 minus 5 divided by 2.5 minus 5. This will give us 10 minus 4, 5 is equal to 4 minus 5. So 6 is equal to 3 phi, and 5 is equal to 2 electron volt. So answer to this question is 2. Now let us move ahead. So the variation of refractive index of crown glass thin prism with wavelength of incident light is shown. Which of the following graph is correct if dm is the angle of minimum deviation? So we know for a thin glass prism, we have angle of minimum deviation or delta m is proportional to mu minus 1 into A. Now, as mentioned here, that refractive index is decreasing, and we know that delta m will be proportional to mu from this relation. So, if refractive index is decreasing, then delta m will follow the same path. So, option A will fit in the curve. So, option A will be the right answer. Now, let us move ahead. A monochromatic light is incident at a certain angle on an equilateral prism which suffers minimum deviation. If the refractive index of the material is root 3, then the angle of minimum deviation is. So for that, we can use that delta m is equal to mu minus 1 into A. And also in case of minimum deviation, the angle of refraction R1 is equal to R2 is equal to A by 2. Now this is a equilateral prism, so angle of prism is 60, so R1 and R2 will be equal to 30 degree. Now suppose this is our prism. Now this is the incident light. This will be the angle 30, and here we will have the R1. So we can apply Snell's law at this point, that 1 into sine of theta is equal to root 3, that is the refractive index of the prism, into sine of 30. And when we solve this, we will get theta is equal to 60 degree. That is option C here. Let us move ahead. A ray of light is incident at an angle 60 degree on the face of prism of angle 30 degree. The emergent light ray makes an angle 30 degree with the incident ray. The angle made by the emergent ray with the second face will be. So basically, if this is our prism, now we have incident angle 60. So I is 60 here, and we have angle of prism as 30, so A is 30 here, and the emergent ray light makes an angle 30 degree with the incident ray, means this is the angle of deviation, so delta is also 30. So we have to find out emergent ray and the second phase, means we have to find out angle E. Now for a prism, we know that delta is equal to I plus E minus A, and now I is 60, E we don't know, A is 30, and delta is also 30 here. So from this we can find out that E will be 0. That light is, we can say, moving perpendicular to the second phase, and that will give us option C. Now for the next one. In experiment for determination of refractive index of prism by I delta plot, it is found that ray incident at angle 35 degree suffers deviation of 40 degree and that emerges with an angle of 79 degree. In such a case, following is the closest maximum possible value of the refractive index. So we know that refractive index for a thin prism, we have a relation that delta is equal to delta m is equal to mu minus 1 into A. But for a normal prism, we have relation that mu is equal to sine of A plus delta m by 2 by sine of A by 2. Now delta can be calculated using I plus E minus A. Now I is 35, deviation is 40, and emergent angle is 79. So from this we can calculate A. So deviation is 40, I is 35 plus 79 minus A, and from this A will be equal to 74 degree. So now mu will become sine of A, that is 74, plus delta m we don't know right now, divided by sine of 74 by 2, that is 37. So from this mu is equal to sine of 37 plus delta m by 2 divided by sine of 37. Now we have to go to the maximum possible value of the refractive index. Now to maximize this relation, we have to maximize delta m, and that can happen when that this whole term, this sine 37 plus delta m 1 by 2 becomes equal to 1. This will be the maximum value of this whole expression. So maximum value of this whole expression will be equal to mu 1 by, we assume it to be 1, by sine of 37. Sine of 37 is equal to 3 by 5. So from that we will get 5 by 3, and that will be equal to 1.67. So from this we can choose that maximum possible value is close to 1.7. That will be the option A. And we can also find out minimum value. In case of minimum value, delta m will be 0. And for that mu will be 1. So mu can vary from here 1 to up to 1.7. And we have to find maximum, so it will be 1.7. Now let us move ahead. Monochromatic light is incident on a glass prism of angle A. If the refractive index of the material of the prism is mu, a ray incident at angle theta and on the face AB would get transmitted through the face AB provided. So we have to find out value of theta such that this light gets transmitted. Now to solve this one, let us first draw a prism here. I think we have a triangle. Yes, it is there. So suppose this is a prism. We have some incident light. Suppose this is our incident light, and after refraction it goes like this. We have normals. So suppose this is our first normal, this is our second normal, and it is mentioned that light should pass through the phase. So what we will also consider, we will also consider the case of TIR, or total internal reflection, that when light will go along the phase. So now let us mark the angles. Now this will be incident angle, this will be the R1, this will be the R2, and this will be the emergent angle. Now we know for a prism, R1 plus R2 is equal to the angle of prism. And if I apply Snell's law here at this point, and here this angle is mentioned at theta, so let us take it as theta. If I apply Snell's law at this point, so what we will get 1 into sine of theta is equal to refractive index, that is mu, into sine of R1, and here sine of theta will be equal to mu into R1 is equal to A minus R2. So this will be sine of A minus R2. Now coming to this point, so if we want light to be transmitted on the other side of this phase, this R2 must be smaller than the critical angle, and critical angle will be equal to sine inverse 1 by mu. So basically we can write that for the limiting case, we assume that R2 is equal to sine inverse 1 by mu, and we can substitute it in the given expression. So from this we will have sine of theta is equal to mu times sine of A minus sine inverse 1 by mu. Now from this, theta will become sine inverse of mu into sine of A minus sine inverse 1 by mu. Now let us come to the whether theta will be greater or smaller, because we just solved for equality, we haven't solved for inequality. So what we want R2 to be less than critical angle. So R2, we need R to be smaller. Now how R2 and theta are related? So from this expression, we have sine of theta is equal to mu into sine of A minus R2, or basically we can write it like sine of theta is equal to mu sine of R1. Now this mu is constant. This mu is constant. So if we increase theta, because sine is an increasing function, up to 90 degrees sine behaves like this. So sine is an increasing function. So if we increase theta, R1 has to increase, only then this equality will be satisfied. So if theta increases, R1 also increases. So means theta increases, it means R1 also increases. And now R1 and R2 related with this expression, that R2 is equal to A minus R1. Now if R1 is increasing, so R2 will decrease, and we want R2 to be lower value of than theta c. So if R2 is decreasing, we want lower value of R2, means we want higher value of R1, and if we want higher value of R1, then we want higher value of theta. So theta must be greater than this expression. So theta must be greater than sine inverse mu sine A minus sine inverse 1 by mu. And we see here that is given as option C. So option C is the right answer for this one. Now let us move ahead. So here we have graph between angle of deviation and angle of incidence for a regular transmission. So that graph is like this. We know that we have a minimum angle of deviation beyond which angle of minimum deviation stops decreasing, and delta m is I plus E minus A. So if we have here delta and here we have angle of incidence, then it keep on decreasing up to a certain value, and that value is known as delta m, and after that it again starts increasing. So that graph is matching with option C. So option C is the right one here. So with this, we end this video here. Hopefully whatever we have covered is helpful to you. Again, if you have any doubts or suggestions, you can put them in comment section. I would like to resolve them and I'll answer your questions. And if you find these videos helpful, then do share them. And if you want to donate, then you can scan any of these QR codes. With this, again, thanks for watching, and we will meet in next video.